All right, and so the next one says I want to find sine inverse of the sine of 4 pi over 3. So the sine of 4 pi over 3 is going to be some sine value, and so we can draw that out. So 4 pi over 3, so there's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. And so the sine value for that is going to be negative root 3 over 2. So it'll be sine inverse of negative root 3 over 2. Now I need to find the angle that has that sine value, but it needs to be in the first or second quadrant. So the angle that has the same sine value that's in, first or fourth quadrant, that's in the fourth quadrant is going to be this angle here, which is negative pi over 3. So that one is negative pi over 3. And the reason it didn't just spit back out 4 pi over 3 is because sine inverse has a domain restriction. So the outputs of sine inverse are between negative pi over 2 and pi over 2. So it outputs angles in this range between negative pi over 2 and pi over 2. And so I needed to find an angle that had the same sine value as 4 pi over 3, but was in that range. Oh, whoops, I accidentally erased. Negative pi over 3. Okay. So this one says the tangent of the angle that has tangent value minus 1. So this here stands for an angle. So this question is, what is the tangent value of the angle that has tangent value minus 1? And for this answer, the answer is minus 1. So the tangent value of the angle that has tangent value minus 1 is minus 1. Okay, if a ski slope has the measurements shown below, what is the angle of elevation in degrees? And so we know that tangent theta is equal to the rise over run, so 2100 over 2600. So to compute this, I can say theta is equal to tangent inverse of 2100 over 2600. And I want this angle to come out in degrees, so I need to make sure that the calculator I'm using is in degree mode. So I can go ahead and do that, and then I can type in the inverse tangent. That should be a button on your calculator. On my calculator, I hit second tangent, and it's the inverse function is right there. And 2100 divided by 2600, and that gives me 38.92. It says round to the nearest tenth of a degree, so 38.9 degrees. Simplify tangent of arc cosine of 20 over 9. Your answer should not involve trigonometric or inverse trig functions. Okay, so I want the angle. So this is the angle. So this inside here is an angle that has cosine value 20 over 29. And so I'm just going to be... so when cosine is positive, that would be in the first quadrant. And so I'm just going to draw a triangle here. And so the cosine value is 20 over 29. So that would be 20 for the x and 29 for the hypotenuse. And then I can solve this side using Pythagorean theorem. So the y, so I know 20 squared plus y squared is equal to 29 squared. And so y squared is equal to 29 squared minus 20 squared. So y is equal to the square root of 1,241. And let's see if that's a perfect square. Probably not. Nope, it's not. Oh, did I do 29 squared minus 20 squared? Ah, I did not. So sorry, I screwed up there. It ends up being 441. And since I am in the first quadrant, the y coordinate and x coordinate are both positive. Let's see if that's a perfect square. Oh, it is. It's 21. And so my tangent value of this angle theta is, so the tangent is 21 over 20. Okay, and the next one, find the exact solutions to that on 0 to 2 pi. So let's go ahead and do it. So I'm going to try to solve this for sine theta. So I end up with 5 sine theta minus 5 equals 3 sine theta minus 7. And I want to solve this for sine theta, so I'm going to start by highlighting the terms that have sine theta in them. And I want to add and subtract so that those terms are on the same side. And the terms that don't have sine theta in them, I want to add and subtract so they are on the same side. So I'm going to subtract 3 sine theta from both sides. So I get 5 sine theta minus 3 sine theta equals negative 7, and I'm going to add the 5 over. So then that gives me 2 sine theta equals negative 2. That means sine theta equals negative 1. Now, where is sine equal to negative 1? Sine is equal to negative 1 in one place at 3 pi over 2. So theta is equal to 3 pi over 2, and it's just wanting solutions from 0 to 2 pi, so that's the only solution between 0 and 2 pi when sine of theta is negative 1. All right, now I want to find all exact solutions to this. So if I solve for cosine theta, I get cosine theta is equal to negative 1/2. And if I think about my unit circle, where is that the case? So cosine is related to the x-coordinate. It'll be negative in these two places in the second and third coordinates, second and third quadrants. And so that is at, let's see, 5 pi over 6 and at 7 pi over 6. So there are two values that have cosine value negative, oh shoot, nope, I'm wrong. It's not those two. So I would do negative square root of 3 over 2. So for negative 1/2, that will be at here at 2 pi over 3, and then here at 4 pi over 3. Excuse me, sorry, I said the wrong one. So those two values are where we have cosine value negative 1/2. So we're going to say theta equals, so I have two solution sets. So I have 2 pi over 3, and then I have 4 pi over 3. But I also have every angle that's coterminal to those two. So I can say plus 2 pi times some integer k, and same here, 2 pi times some integer k. So any angle that's coterminal to these two angles will also be a solution. Or if I want to think about it in terms of graphically, I have my cosine graph here, and I can see that it hits the value negative 1/2 2 times here and also here. And so, but it's going to, the graph goes on forever in both directions, right? And so what I do is I have angles that are coterminal to it, and it's shifted by 2 pi. So anytime that I add or subtract 2 pi from that, I'm going to be hitting those other values. And so I could think about it that way as well. Now it says find all approximate solutions to cosine theta equals negative 0.43 on the interval from 0 to 2 pi. Now since it says that my interval is from 0 to 2 pi, know that I need to be in radian mode. And so I can set my calculator in radian mode, and then I can do the inverse cosine of 0.43, negative 0.43. And so I got 2.015 for one of my answers. I went around to 2 decimals, so 2.02. But where else is cosine negative? So cosine is negative in the third and fourth quadrants. So 2.02, what quadrant is that in? Well, how does that compare to pi? So 2.02 is less than pi, so that would be this value here, 2.02. And to find the other value, I need to find an angle in the fourth quadrant that has the same reference angle. So this 2.02 goes to here. So to find my reference angle here, I want to do pi minus the 2.02. I'm going to do 2.015, Yeah, to be more precise. So I get that my reference angle is 1.126. So I want to add 1.126. So if I do, this is going to be pi plus 1.126. If I do pi plus 1.126, I get 4.26. So that's going to be 4.27. And then that's going to be, again, plus, actually it just says the interval from 0 to 2 pi. So those are my only answers there. Now it says find all approximate solutions to that guy there. So I'm going to subtract 7 and divide by 5. So when I subtract 7, I get -4, and I divide by 5. So I get sine x is equal to -4/5. And so I can do my inverse sine of that, again, making sure that I am in radian mode, and I get that x is equal to -0.927. And one thing I want to note is that that is not even in my range. That is not in my range. So how do I account for that? Well, I'm going to graph it and see if I can find an angle that's coterminal to that angle that is in that range. Now, the first thing I want to think about is where is sine negative? So since sine deals with the y value, sine will be negative here and here. So I have that this angle is -0.927. And so, so the question is, what would this angle be here that goes this way? Well, I could just do 2 pi minus 0.927. And so I can figure that out. And I get 5.356. Okay. The other angle that is coterminal is going to be this angle here. Now, I know that this distance here, this angle here, is 0.927. So to find my other angle that has a negative sine value, I want to do pi plus 0.927. And so if I do that in my calculator, pi plus 0.927, that gives me 4.068. Oh, shoot. Okay, and so then my two answers are 4.068, 4.068, so 4.07, and 5.36. So I can say x equals those two. Next, it says find all approximate solutions to tangent theta equals -4.5 on the interval from 0 to 2 pi. So, so one thing to remember is I'm doing the interval from 0 to 2 pi, so tangent is going to repeat itself twice. So let's do that. So tangent theta equals -4.5. So I'm going to do inverse tangent of -4.5, and we'll see what we get. I got theta equals -1.35. And so that would be where? 1.352. Okay, so negative pi over 2 is -1.57. Okay, so where is tangent negative? So tangent is negative in the fourth and second quadrants. So this -1.352 is there in the fourth quadrant. So I'm going to draw it in this way. That goes this way, -1.352. So the question asks, it has to be in the interval from 0 to 2 pi. So it needs to be a positive angle that has the same, that is coterminal to that angle. So I can get it by going this way and doing 2 pi minus 1.357 and see what I get. So if I do 2 pi minus 1.357, that gives me 4.926. Okay, and then for the other angle, I want to do this angle here. I know the reference angle of it is going to be 1.352. So if I do, to find this angle, I want to do pi minus 1.352. And that should give me that yellow angle. And so that gives me 1.7895. And so those are my two answers then. So I get theta equals 1.7895 and 4.926. Oh, I was supposed to round. 4.93 and 1.79. Yeah, whatever. Okay, next one, find all solutions in radians to the given equation on the interval from 0 to 2 pi. So I want to solve that equation for cosine of x. So first I want to make sure that I highlight all the terms that contain cosine of x. I want to add and subtract so that those terms are on the same side. And the terms that don't contain cosine of x, I'm going to add and subtract so that they are on the same side as well. So I'm going to go ahead and subtract 8 cosine x from both sides. So if I do 3.5 minus 8, that gives me negative 4.5 cosine x. And I can add 1 to the other side, that equals 3. So I get cosine x is equal to 3 divided by negative 4.5, which is equal to negative 2/3. Okay, and so then I want to round that to 2 decimals. So I want to think about what quadrants cosine is negative in. Remember, cosine is associated with x, so it will be negative in the second and third quadrants. So, all right, so let's see if my calculator gives us anything. Cosine inverse of negative 2/3. And that 2/3 is not a cosine value I have memorized, so I am going to be estimating. And also I know here it says round to 2 decimals, so that gives me information about that as well. So I get 2.300. So which one is this? Well, I know pi is about 3.14, so this one here is the 2.30 is this angle here. So I've got one of them. The other one I need to figure out my reference angle for. So this reference angle, if I do pi minus 2.3, that's going to give me the reference angle, which is 0.84159. And so that means that reference angle is going to be the same one, 0.84159. And so that means that this angle here that I'm trying to find, that's here in the third quadrant, is going to be pi plus 0.8416. And so if I do that, I get 3.983. And so my two angles are 2.30 and 3.98. I don't know what I'm doing. So those are my two angles. And that's it.